So let's do an example here with the Doppler effect. So we got a road. We got a blue car driving along. And let's say the blue car is moving with some velocity of 31 meters per second. In front of the blue car is a white car, and the white car is moving with some velocity, let's say it is 25 meters per second. Okay, and moving in the same direction. On the other side of the road is a red car, and the red car is moving in the opposite direction and is moving at 29 meters per second. Already past this is another car, and let's say this car is an orange car. Orange car is on the other side of the road heading in the other direction, and let's say the velocity of the orange car is 30 meters per second. There's a pedestrian standing here, and there's an armadillo laying in the road right there. Okay. All right. And so the guy in the blue car is impatient and sounds a horn, and the horn has a frequency of 1100 hertz. So the question is, what sound does everybody hear? Including the dead armadillo. Okay. Because we all know zombies are dead and they can still hear. All right. So we can assume here that this is a Doppler problem. So the frequency that is heard is 1 either plus or minus V sub D over C divided by 1 minus or plus V sub S over C times the original frequency. Well, the only thing that we need to know is the speed of sound. So let's say the speed of sound on this particular day is 342 meters per second. And so now we just figure this out, and we say, okay, let's do the orange car first. So for the orange car, then the frequency that's heard is going to be 1 minus 30 meters per second over 342 meters per second divided by 1 plus 31 meters per second over 342 meters per second times 1100 hertz. Minus because it's going away, plus because going away. Okay, remember in the numerator, the upper sign is for towards, the lower sign is for away. In the denominator, the upper sign was for towards, the lower sign was for going away. So you plug all this in, the driver of the orange car hears a tone of 920 hertz. Okay. So what about the driver in the white car? Okay. So for the white car, the white car is moving away from the person sounding the horn, so minus 25 meters per second over 342 meters per second, but the car is heading towards the white car, so 31 meters per second over 342 meters per second times 1100 hertz. Remember, the plus and minus are backwards in the numerator and denominator. All right, so F prime is going to be 1120 hertz. So that's the tone the person in the white car hears. Okay, so what about the person in the red car? Okay, so F prime is going to be equal to 1, okay, and the red car is heading towards the car making the sound, 29 meters per second over 342 meters per second, and then it's 1 minus 31 meters per second over 342 meters per second because the blue car is heading towards him, okay, times 1100 hertz. And so the tone that's heard by the driver of the red car is 1310 hertz. Okay, so what about the pedestrian? Well, pedestrian's not moving, so the numerator is just 1 because the velocity of pedestrian is 0. The driver is heading away, so that's plus 31 meters per second, or 342 meters per second times 1100 hertz. So the tone that the pedestrian hears is 1010 hertz. Okay, so what about the armadillo? Well, the armadillo is just laying there in the road, and then sound is going into its ear. Okay, and so the tone that the armadillo would hear, if dead armadillos can hear, okay, is 1 minus 31 meters per second over 342 meters per second times 1100 hertz, because the driver's heading towards the armadillo, and so that would be 1210 hertz. Okay, and then finally, the driver of the blue car. What is the driver of the blue car here? Because something a lot of people forget. Well, the driver of the blue car is where the actual sound is being made, and so the driver of the blue car hears the correct frequency of 1100 hertz. And so now we have found for each of those situations there, what would that particular person hear?